Hello. Today I'm going to talk about our recent research activities at the intersection of blockchain and energy, in particular on how to understand the impact of crypto mining on the power grid. There are three major trends that are happening in the energy sector. On a source side, it is the decarbonization of energy sources. By that, not only I mean the increasing amount of wind and solar renewable generation, but also things like low carbon nuclear technologies and carbon capture and sequestration technologies. On the demand side, there is an increasing amount of electrification on both existing amount of demand and new kinds of energy demand, such as crypto mining. On the network side, it is the increasing interdependencies across multiple networks, and that is causing a lot of opportunities and challenges to understand how the electric power network interface with networks such as transportation, hydrogen, and natural gas, and so on. Across the entire ecosystem, it is the proliferation of sensing, communication, control technologies, and overall, the research goal is to design clean, affordable, and resilient energy services. And these three attributes, clean, affordable, and resilient, do not necessarily always align with each other. And that is part of the research community's goal to bring them closer to each other. When it comes to the impact of blockchain on the energy and the environment, we think that universities are to play very important roles in the following four aspects. One is on education. There are very few talents out there who are very well versed at the intersection of blockchain, programming, and understanding of the energy systems. That is a big role that universities are to play. And there's also a great need for research, such as utilizing these crypto mining devices for demand response, load forecasting, and so on. It also had all full stack research opportunities all the way to the underlying computing architectures. In terms of public perception, there's a lot of biased, polarized view of where this crypto and blockchain lands. And universities are to provide neutral, impartial, data-driven analysis to not only assist the public, but also to assist key policymakers in state and federal levels. Here at Texas A&M, we have formed the Blockchain and Energy Research Consortium to tackle exactly these questions. This is a recent site visit to Rockdale, Texas, which housed one of the world's largest crypto mining facilities with some 800 megawatt of energy consumption. There has been efforts in many other places trying to estimate the impact at a high global level using coarse models. And part of our research is to provide high resolution information about all of this. In the United States, it is quickly becoming an epicenter of crypto mining activities. And this is largely due to two competing forces. The first is that there has been an increasing amount of research and innovation that is making the computing more and more energy efficient. In other words, for the same kind of hash functions, it is taking less power. However, there is a disproportionately higher increase on the network hash rate. And these two forces combined, you see the net result of some 2,000% increase in the electricity consumption between 2016 and 2022 due to the crypto mining activities. And this is further visualized by the following chart. In July of 2022, between July 8 and July 13, there was a visible 18% drop in the global hash rate, which is roughly the global computing devoted to Bitcoin network. And that caught us by surprise. But coincidentally, we realized that was exactly also the time when the Texas power grid was going through some stressed moments. These two phenomena are highly correlated in a way that we would have never imagined, which is the grid is very stressed. It has in Texas, and the global Bitcoin hash rate was down by 18%. So that spoke about the strong correlation between what is happening in the power grid, in particular in the area of Texas power grid, and the worldwide crypto mining activities. So that's part of our thinking is, could we utilize this large scale mining activities for things like scalable demand flexibility on grid resiliency? And if so, how much could we rely on this? So this is a recently published paper in Advances in Applied Energy, in which we discovered that the correlation coefficient between the system-wide net load, which is the total amount of demand minus the renewable generation in the state of Texas, that correlation, that demand has a very different correlation coefficient pattern with traditional demand versus the crypto mining demand. So this number here suggests that for the traditional demand, there is a very high positive correlation coefficient. That means that when the grid is very stressed, so is most other type of demands. For example, your households, for example, a major university, for example, a major commercial or industrial facilities. That suggests that when the grid is under stress, while we should try our best to still squeeze the most out of every single type of demand for demand flexibility, the room for squeezing is rather limited. Whereas if you pay attention to the number here, which is the total mining demand correlation coefficient with the system-wide net load, it is on a very different path. It is actually a very negative number. That suggests that when the grid is very stressed, these mining demands were exactly doing shutting down. And that's something that could be leveraged for demand flexibility responses. And this is also visualized through this county level map of the electricity market price as the underlying color and the amount of mining demand as the bubble size shows. As you can see, there is a quite negative correlation between the high price points and the amount of energy consumption being reduced in these mining facilities. So with that, we actually have a more detailed, high resolution data published, available for analysis in terms of understanding the cryptocurrency mining on a synthetic Texas grid in the carbon footprint, grid reliability, and market price perspectives. In terms of the reliability, the key of the finding is that the way that these mining demands are modeled are going to play a crucial role. If this mining demand were to be modeled as firm demand with the projected growth of renewable energy and projected growth of demand, there will be a significant degradation on reliability index such as loss of load hours. However, if you model this mining demand as either full flexible load, meaning they can be shut down at any time, or even just as partially flexible load, meaning, for example, they are only being flexible between 6 hours a day, between 2 to 8 p.m. on the day, that already is suggesting a quite different perspectives in terms of their impact on the loss of load hourly. In fact, this impact is very, very significant as you contrast these two curves with the other curves. So the importance is that modeling them and treating them as flexible load is very crucial for maintaining the system level reliability. In terms of their carbon footprint, in contrast to most of the other published reports, we have a much higher spatial resolution data and model. And the discovery is that for the same amount of megawatt of crypto mining consumption, their carbon footprint per megawatt hour could vary significantly from locations to locations. And that is something very important to keep in mind as we talk about the global carbon footprint of this industry. Location matters a lot. And another interesting point is that these locations that are closest to the renewable sites are not necessarily always lead to the lowest amount of carbon footprint, because what matters the most is the electrical connectivity rather than the geographical proximities. When it comes to the impact on the wholesale level market prices, here's another interesting finding. That is, the system with price responsive way of modeling the crypto mining demands would have a very different market price behavior as compared to a system where these mining demands are modeled simply as firm, constant mining loads. If you model them as firm, constant mining loads, you do see a significant increase of high price points, in particular in the west part of the state. Whereas if you model them as price responsive demand, their price will be, the impact would be significantly damped. There is also a machine installed in our lab, donated by Texas Blockchain Council. And this is a machine that is designed for the students to learn,
steady state,
and to do research, and to promote innovation and commercialization in this space. So to summarize, blockchain and crypto is still at its very infancy stage. There is an increasing amount of energy needed for such applications. The energy sector should think about it in a serious manner, and the part of the research and education agenda here is to how to use the data and the model and analysis to hopefully direct a win-win situation for the energy sector and the blockchain industry. And this is a major challenge as well as an opportunity for the years to come. Thank you very much for your interest, and you can always contact us if you have any further questions.